Welcome to Third Angle, where digital tech is transforming space-based surveillance. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. In this episode, we're venturing into space via Rome, Italy, where ARCA Dynamics are mapping the cosmos.
Welcome. Here we are in ARCA Dynamics headquarters in Rome. Here we perform all the activities in order to provide services related to the observation of satellites in space.
It's hard to remember, in this sunlit office with rolling fields just outside, that the team's attention is fixed far, far above the Earth, where satellites race past one another. You could think of it as a kind of orbital highway, and ARCA Dynamics are the traffic wardens, making sure nothing collides.
I'm Marco Moriani, co-founder of ARCA Dynamics, together with Dario Spiller and Daniele Lucena. ARCA was founded in 2016. ARCA Dynamics is the first and only company to perform space-based observation of orbiting objects. We are the only company in the world to provide the service. I had the opportunity to meet Daniele and Dario and the university. We were all together into the robotic laboratory, and we are all engineers. We were working together image processing during a period of experiment in the laboratory. We understand that our technology could use not only to observe natural objects in space like stars, but also to observe orbiting objects, so satellites or debris. And so, starting from that, we understood that it was possible to develop a technology to observe directly from space other orbiting objects. We need to consider that observation from grounds are limited because they can observe an object only when the object is passing over the head of the observer. While from space, a satellite is orbiting, so it's moving, and it is also possible to change the direction of the observation. So you have multiple chances to observe a target.
And this vision for surveillance in space? It didn't stay an idea for long. After finishing their master's degrees in aerospace engineering, the trio stayed in touch. It all started in the most unlikely of places.
So we were together into a Chinese restaurant. And it was really interesting because a few days before, I was thinking about the opportunity to create some industrial opportunity. And when I put on the table this idea, the other guys immediately told me that they were thinking about the same thing. So in a certain way, we were unconsciously thinking about and planning to start the same project.
The co-founders even kept a small memento from that day, a reminder of where it all began.
And so part of the memorabilia is the receipt of that launch altogether. And I think it's really a treasure for us because it's the starting of this incredible journey. That restaurant now is closed. So in a certain way, we survived the restaurant. It's that for a startup is a really incredible goal because usually startup life 5 years. And so maybe we are, let's say, one of the really small group of companies that are able to survive. In fact, ARCA Dynamics survived because we worked during the weekend, during the holidays, or during the night sometimes, unfortunately. And the big goal was when we were able to employee Rebecca, because in a certain way we passed to Rebecca a lot of, sorry, I'm laughing because I can see Rebecca's face, because she really well remember about the beginning of ARCA Dynamics experience. So we were able to share together with Rebecca part of the beginning difficulties. And I would say that we really need to say thank you to Rebecca, because she's a really fundamental part of ARCA Dynamics. She's project manager of different activities. In particular, she's responsible for the development of our satellites that we are going to launch in the next year. One more time, with respect, every day I said to Rebecca, thank you so much for being part of ARCA Dynamics.
Oh yeah, you're welcome. So I started my journey here just after uni. Yeah, I learned a lot. I'm really happy to see ARCA growing and starting from a few of us and getting to a team of like 20 people or so. So it has been really, really nice and satisfying.
But before we meet more of ARCA Dynamics' growing team, we need to understand what exactly they do and why it matters. Because at the heart of their mission lies one crucial measurement.
Our service is related to the provision of state vectors. State vector is the fundamental information in order to know the position of the satellite in space.
A state vector, put simply, is a mathematical snapshot, a precise mathematical record of where exactly an object is in space and how fast it's moving. For satellite operators, it's the foundation of everything.
So once you are able to define the state vector, you can simulate the evolution of the position of the satellite. Given that a satellite is something that is flying really fast with a growing number of other satellites, you are constantly in the risk of collision. And so this is why you need to know as frequently as possible, with the highest precision possible, the position of your satellite and the position of the other satellites. No one is living in the satellite. Usually we think about airplanes or cars when you have a pilot or the driver that is on board and can immediately understand if something is going wrong, and he can put in place mitigation activities like braking the car or change the altitude of the plane. But again, you have the driver or the pilot on board, while for satellite it's not true, because the satellite is an autonomous entity. So you need to have from ground all the informations to calculate the probability of an impact and to decide if it's necessary or not to perform a maneuver. And please consider the maneuver as a cost, because you have to use onboard propellant, or in any case, stop the service of the satellite during the maneuver. So you have to be sure that the collision is something that is going to happen. This is why we provide state vectors.
That's why ARCA Dynamics state vectors are so critical. They help satellite operators prevent costly collisions, reduce unnecessary maneuvers, and keep vital services online, from internet access and weather forecasting to military operations. In a sense, they act as a kind of space insurance, but the stakes go even higher than that.
The point is that two satellites that collide create a lot of debris, and debris are really high-speed bullets flying without any control that can hit and destroy other satellites. So a single impact creates such amount of debris, thousands, millions, and a growing population of debris makes impossible to grow the exploitation of orbits for commercial purposes or for institutional purposes. And so if we not put in place any policy in order to control the proliferation of debris, at a certain point, the human beings will not be able to exploit space.
So it's a high-wire operation. One mistake in orbit can have cascading consequences. And that's why ARCA's expertise has attracted top-tier clients, including the European Space Agency. Down on the ground, Marco gives us a closer look at those satellites.
When we decide the layout into the office, we want to have a big impression entering the office. And so we put our satellite models at the entrance of the office. And here we can see the first one, that is the smallest one, a 3U satellite. A U stands for unit, and a unit is a standard, 10 centimeters by 10 centimeters by 10 centimeters. Let's say that a 6 unit is something like a shoebox, but you can put together, like a Lego, you can put together different units. Each unit can contain different subsystems, batteries, power unit, or attitude control system. Or the payload, we have 2 cameras and the processing unit inside. So the first satellite is a 3U, and we call him Falco 1. It's the series name we use for all the satellites. In fact, the second one is a 6 unit, and it's Falco X, because we added the radio frequency to the optical sensor. And then the last one, the biggest, is a 16 unit. It's Falco C square, because it's a Falco connected constellation. It will be part of the biggest constellation that we want to deploy in the next years. And it will perform observations from different directions in order to increase the capability to view satellites. And it will have a dedicated camera for debris.
Now that we've met the satellites, it's time to see how they really work, step by step. Pulling data from something orbiting hundreds of miles above the Earth and turning it into usable data back in Rome takes precision, coordination, and teamwork. In their open plan office, shared tables are set up so the team can work side by side, each piece of the operation coming together to make the service possible.
So here we have at the first table Vittorio, that I would say is the beginning of the journey.
Hello everyone, I deal with the tasking of satellite.
So he decides where and when we have the better opportunities to observe targets.
Satellite tracking request received.
Preparing maneuver for observation.
Command sent.
Okay, so once we receive back the data and we have the station where Paolo works in order to perform the image processing and to identify if someone was captured in the image.
Images captured.
Target detected.
And it's not easy activity, because you have to imagine that the picture is not something like what we take with our phones, but is something really full of noise, a lot of stars in the image. And so it's not easy to identify such a small object that is flying at a very high speed. And so a lot of algorithms are used in order to process the image, to isolate the presence of the target that we want to observe.
Orbit determination performed.
Task concluded.
Now I'm describing different steps, but once we will have hundreds and hundreds of requests per day, it will not be feasible to have a person in charge of practical activities. So we need to have an autonomous pipeline. And Paul is also in charge of creating this autonomous pipeline that put together all the different steps in order to automate the process.
Hello, everyone. I'm a flight dynamics engineer, so I work with the flight dynamics algorithms and the whole ground service infrastructure, and I kind of have the oversight of everything.
So the last step is the orbital determination. Please consider that we capture a really small amount of frames, representing a few seconds of the entire orbits that usually last at least 90 minutes. Once we extract information about the position in the picture of the target, we start the reconstruction of the orbit. Because at the end, we want to know where the satellite is and what kind of orbit he is following in order to, at the end, create the state vector. This is the last step, to define the orbit and to absolutely say where and when the satellite is. Of course, the team is not composed only with the guys in charge of the service activities. Part of the ARCA activities are also the design, integration, and test of all the components that we need to create our satellites.
ARCA is planning to launch a larger satellite capable of processing images directly in orbit, cutting out delays from transmitting data back to Earth. And at the heart of this leap in space-based monitoring is the technology of the moment, AI.
AI is already a crucial part of the technology that we want to integrate on board of the satellite. That's exactly why we are investing in it. First of all, it will help us to better acquire images because the satellite will have the capability to autonomously define better conditions. The integration of the AI into our processing algorithms will extend the capability to identify the target. So for sure, the implementation of the AI on board will increase the number of targets that we will be able to observe during a single acquisition.
But ARCA Dynamics isn't stopping there.
We think that we need to improve our technology. In fact, we are looking at a new level of service in 10 or 20 years.
Their vision is satellites that can chart and adjust their own paths autonomously, performing maneuvers in space without waiting for instructions from the ground. And it's an urgent necessity.
Now we have in space no more than some thousands of satellites, but we need to consider that the mega constellations like Starlink or the future OneWeb represent more than 50% of the satellite in orbit, and they are growing. So it means that a lot of satellites will fly side by side, and it will not be possible to accept that someone from ground received information, analyze, put in place some simulation, and decide if the satellite need to perform some maneuver.
Goldman Sachs research predicts that 70,000 low Earth orbit satellites could be launched in just the next 5 years. With so much traffic up there, automated processes aren't just convenient, they're essential. And there's another crucial reason automation matters. It all comes down to those fast, tiny bullets of debris hurtling through space.
The point is that the debris population nowadays is just estimated. We don't know exactly how many and where the debris are. So every activity performed to avoid the risk of collision between satellite and debris is performed starting from an estimation. Why is not possible to have a deterministic knowledge about the debris, because it's not possible to observe debris from ground. No optical, no radar from ground are useful in order to observe debris, because debris are really small objects flying at a really high speed. This is another important utilization of ARCA Dynamics technology. The observation from space, directly from space, with the specific optics that we are developing, will enable the opportunity to create a real catalog of the debris. The problem is difficult because when we are talking about debris, they are affected by a lot of external forces, interaction with other satellites, with the Earth magnetic field. A lot of things can change the orbit of a debris. But starting to collect real information about the debris let us start put in place mitigation activities, starting from not estimation, but from real data. Currently, we don't have the technology to remove debris from space. For sure, there are a lot of companies that are working on this topic with different approaches. Someone wants to destroy at a particle level, someone wants to collect, but in every approach, there are a lot of difficulties. This is why the more effective approach is to collect as much information as possible in order to avoid collision between satellite and debris. In the near future, this is, to me, the only solution.
That was Marco Moriani, COO and founder of ARCA Dynamics. Now it's time to get our experts' take. Welcome Brian Thompson from PTC. Brian, aerospace products depend on design accuracy and weight management, and that includes cables and harnesses. How has Creo helped companies like ARCA Dynamics optimize their cable harness designs?
Okay, that is a really, really great question. Let me first start by saying there's a really good set of reasons why Creo is so strong in this particular part of the aerospace vertical. When you're putting stuff up into orbit, we're known for very, very high fidelity, highly robust, highly accurate part geometry and assembly creation and management. So I think the first point is overall, customers trust us when their data is completely up to date inside Creo and we tell them where the center of mass is for that assembly, they can count on that's where the center of mass is for the assembly, period. Like it's extremely accurate and well respected for those capabilities. But as it turns out, so much now of weight management is going into some of the other things in classical products that are not thought of as classical electromechanical design components like cable harnesses. It's becoming a significant part of the overall mass of the system. And we see that, which is why in Creo, we've completely revamped how we build harnesses in Creo to take advantage of Creo's power and top-down design and large assembly management performance so that a cable harness can be designed from the top down with all the interfaces at the various locations in the satellite. And you can actually have, when coupled with Windchill, a collaborative design environment for building cable harnesses across the entire product with different engineers responsible for different legs and parts of the harness. And because everything that's a component in the harness is a component in the assembly, and that entire cable harness assembly rolls up like any other assembly inside Creo, the same level of precision that we have applied for decades in our Creo assemblies is now getting applied to harnesses. You couple that with the fact that as electrical designs change in 2D, we can update automatically the harness design in 3D inside Creo. Customers are getting a tremendous amount of leverage from that. So I think more than anything, the big answer here is that we're known for super high fidelity accuracy in delivering 3D CAD models. We've extended the concept of a very highly complex assembly design process into the world of cabling now in Creo, and customers are really loving that, and I'm confident that's why ARCA Dynamics is so strongly in favor of using this capability inside Creo.
Thanks to Brian and to Marco and our producer for taking us behind the scenes of ARCA Dynamics. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and X for future episodes. Companies that make products the world relies on rely on PTC. This is an 1860 production for PTC. Executive producer is Jackie Cook, location recording by Danny Mitzman, sound design and editing by Louise Morris, and music by Rowan Bishop.